Welcome to session 23, Special Triangles and Mixed Reasoning. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to connect equal sides with equal opposite angles in an isosceles triangle. Use equilateral and right triangle properties alongside general angle rules. Combine side, angle, and Pythagorean information without assuming facts not marked. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. A right triangle can combine special patterns with side lengths. The exterior angle reasoning can join special triangle facts. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. An isosceles triangle with vertex angle 36 degrees has two equal base angles. They share 180 degrees minus 36 degrees equals 144 degrees, so each is 72 degrees. Dividing by 2 is justified by the equal side markings. Special triangle properties must be justified by markings or stated facts. Equal sides face equal angles. An equilateral triangle has 360-degree angles, and right triangle facts require a right angle. Trust markings and stated relationships, not visual appearance. Diagrams are communication tools, but they are not guaranteed to be drawn to scale. Now add a precision check. Write each relationship beside the diagram before forming an equation: equal, complementary, supplementary, or a full term sum. Preserve degree units, solve the algebra, and substitute the value back to confirm every angle is positive and every required total is satisfied. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, copy every tick mark, angle arc, and right angle box into a list of known facts. Second, use equal side and equal angle relationships before substituting numbers. Third, apply the triangle angle sum, then use the Pythagorean theorem only if a right angle is established. Finally, check that the longest side lies opposite the largest angle. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A right triangle has one acute angle of 35 degrees. What is the other acute angle? Step 1 is to organize the information. Copy every tick mark, angle arc, and right angle box into a list of known facts. Step 2 chooses and sets up the relationship. Use equal side and equal angle relationships before substituting numbers. Step 3 carries out the mathematics. The two acute angles in a right triangle add to 90 degrees. 90 minus 35 equals 55. A useful check is to use the special triangle property before calculating. The answer is 55 degrees. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. An equilateral triangle has side length 9. What is its perimeter? Write a formula or a relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 27 degrees. All three sides are equal, so perimeter is 3 times 9 equals 27. A useful check is to use the special triangle property before calculating. Use this coaching check as well. Treat diagram markings as evidence. A shape that merely looks isosceles or right does not guarantee those properties. Session recap. First, copy every tick mark, angle arc, and right angle box into a list of known facts. Next, use equal side and equal angle relationships before substituting numbers. Then, apply the triangle angle sum, then use the Pythagorean theorem only if a right angle is established. Finally, check that the longest side lies opposite the largest angle. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.